Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Department of Artificial Intelligence and Data Science, B.V. Raju Institute of Technology, Narsapur campus. I am teaching the subject is data structures using Python. In that subject, today we will discuss about what are the different applications under the divide and conquer method. So, coming to this application, in the divide and conquer algorithm, there is a number of algorithms are there. Okay. What are the number of algorithms are? Med sort, binary sort, bubble sort, pick sort, minimax analysis, Strassman algorithm, closest pair of algorithm, and Karasba algorithm. These are the different algorithms are available under the divide and conquer techniques. In our syllabus, we will discuss binary search. Another one is minimax algorithm. These two algorithms only for in our syllabus. Okay. First see one by one algorithm. Coming to the minimax algorithm. This is the first algorithm for the divide and conquer technique. Here, in this algorithm have follow the different steps are there. What are the different steps means? The first step is initialize the two variables. Initialize the two variables. What are the two variables? Maximum element and minimum elements. These are the variables. Okay. After taking the two variables, first divide the array into two roughly equals for creating the two sub arrays. What are the first two dividing the array into the two sub arrays? What are the two sub arrays means? One is left half, second one is right half. Left, right. Okay. Next step is to find out the maximum and minimum elements for both left and right. Next, this one is the first step, this one is the second step. Third step is to find out the minimum and maximum elements of left half and right half. Now, we can update the each element for the either maximum element and minimum element. Now, first we can update the maximum element. How to update the maximum element means the maximum element equal to maximum of maximum element left and maximum element right. Okay, to update the maximum element, update maximum element of left and right. That is the fourth step. Next, the fifth step is update the minimum element. Fifth step is update minimum element. How to update minimum element means minimum of minimum left element and right element. Minimum of left and right element. Next, and also return the maximum element and minimum element. Last step is to find out the best case. Which one is the best case? That is the best case. When an array is contained only one element for minimum and only one element for maximum, and also return the both values as either minimum and either maximum. That is the algorithm steps for minimax problem. So, first you can find out, first you can solve the one example for the minimax algorithm. First, what is that given problem is find the maximum and minimum from the sequences is 33, 11, 44, 55, 66 and 22. By using this sequence to approach the divide and conquer approach. See how the algorithm will be work on. Here, what are the elements are there? These are the different elements. 33, 11, 44, 55, 66 and 22. Now, first the problem can be dividing into two left and right. left half and right half. This is left half, this is right half. Okay. Again, the sub-problems can be dividing into two sub-problems, that is left and right. Now, we can update which element is the maximum element and which element is the minimum element. Now, in this case, the 33 is the left, 11 and 44 is the right. Now, here we are taking the two elements. And also here left half we are also taking the another element, that the element is same. Okay, 33. Here the 11 and 44. Here the 55 is only one element. We have to easy purpose we are taking the another element, that element is the 55. Okay, here also 66, 22, two elements. Now we can find out the which one is the minimum element and which one is the maximum element and update that one into the table. Here in the 33, 11, 14 is there. In this statement, in this number sequence numbers, which element is the minimum element means 11 is the minimum element and 44 is the minimum element. Okay. This is the left part, this is the right part. In this right part, and we are also considering which one is the minimum element, which one is the maximum element. The minimum element is 22, the maximum element is 66. Okay. Again, this sequence number we have to find out the another sub-problem solutions. In these four elements, which one is the minimum element, which one is the maximum elements. Here to find out the minimum is the 11 and maximum is the 66. Finally, in the mini-max problem, only one minimum element and also only one maximum element. We have to find out the solution. That is called as a mini-max algorithm. So, coming to the second type of algorithm is called as a binary search. In previous slide, we will discuss about the mini-max algorithm. Now, we are discuss about the binary search. What do you mean by binary search? Binary search is a searching algorithm. Searching algorithm for finding the elements positions in sorted array. Sorted array. We have to find out the solutions based on the sorted array. In this approach, the element is always searched in the middle of the position of an array. We have to find out the middle position of the element. Okay. How to working the binary search algorithm? Here the binary search algorithm can be worked in two ways. First one is the iterative method and the second one is the recursive method. Okay. See one by one. Here, coming to the iterative method, first we have to find out the middle position of the element. That is called as, see this one, this one is the iterative method. Coming to the iterative method, until the pointers into the low and high to meet each other means, first we can find out the mid position. Mid equal to low plus high by 2. Okay. If the x equal to array of mid. Array of mid means whether we are taking the element, that element is the position will the mid position or not. If the mid position to remain, return the mid, otherwise we have to find out the x is greater than array of mid 1. That means x is on right side, the right side is, that is low equal to mid plus 1. X is on left side, high equal to mid minus 1. That is the iterative method in that binary search. Coming to the recursive method, have to find out the binary search elements. Have to what type of the elements is, first we are taking the array elements, have to searching the element, that element is the lowest element or the element is highest element. If first condition is, if low is greater than high, first you can check the whether the elements is low is greater than high means it can be written the false. Otherwise, can consider the mid equal to low plus high by 2. Low plus high by 2. If searching element x equal to array of mid means return the mid element. For suppose if the x element is right side, if x is greater than array of mid, that will be return the array x mid plus 1 and I. If the x is on left side, can be written the binary search of array element, searching element, low and mid minus 1. Okay. If the element is right side, mid plus 1. If the element is left side, mid minus 1. Okay. These are the two algorithms under the binary search. See the one by one. First we are taking the one element, that array element is, this is the example for binary search. Binary search. See this example, array equal to 10, 20, 30, 40, 50, 60, 70 is there. Now I am searching the 50 element in that position by using binary search. First, what are the steps we have to follow means, first step is find the middle element. Find the middle element. Now, if the middle element is matches the target, program is completed. If the target is smaller, try to search left half. If the target is larger, we have to find out the right half and repeat the steps until the sub-array is, divide the sub-problem into smaller problem. These are the steps you have to follow the searching the element in that by using binary search. See this one. How to work on this one? First input is this element 10, 20, 30, 40, 50, 60, 70. Okay. What is the target is? The 50 element will be searched. What are the first step? If the left half, right half. Okay. If the left half is 0, right is 6. Okay. Now, the second one is try to find out the mid position, that is based on the 0 plus 6 by 2. That is third position. In the third position, array of 3. Here, in that in programming language, the array will be start from 0, 1, 2, 3, 4, 5, 6 like this. Now, 0th position is 10, 1 position is 20, 2 position is 30, 4th position is 3, 4, 5, 6. Now, the array of 3 is 40 element. This 40 element is, our target is 50. So, the 50 is greater than 40. Now, can search the right half. The 40 element is available in right half. Okay. The 40 element is available in right half. The second step is, left half is 4 element, right is 6. We can find out the 4 plus 6 by 2 is 10. That means 10 by 2. That is 5. Okay. 10 by 2 equal to 5. In that 5, array of 5 equal to 60. The array of 5 equal to 60. Here, our target is 50 element is less than 60. We can searching the left half. That is index 4 to 4. Okay. Now, the third step is, left is 4, right is 4, that is 8 by 2, that is 4. The array of 4 equal to 50. My target is 50 means, that is array of 4 equal to 50. So, the 50 value is equal to target value. So, now we can find out the target value of 4. Array of 4 index is 4. The element is 50. Means the element 50 is found at index 4. Okay. See this table. First step, we are taking the 0. Right is 4. We have to find out the mid position 3. In the mid position, the element is 40. The element is available in the right half. 4 plus 6, that is dividing by 2 means 10 by 2, that is equal to 5. Okay. The array of 5 element is 60. The 60 element is available in the left half. The third case, 4 plus 4 8 by 2, that is 4. The missed position is the 4. The array of 4 is 50 element. The 50 element is matched with our target. So like this, we have to searching the target value. This is the binary search. See this example. This is the example by using the Python programming. So first the function is the binary search, in that array elements and also target value. First condition is, first we are taking the initially 0, the low value is 0. The high value is length of array of -1, while this is the first case, while low is less than or equal to high. Next, we can find out the mid position. If the mid position is with the mid position value is our target, return the mid position. Otherwise, if the mid position is less than target, mid position value is less than our target value, that is low equal to mid plus 1. Otherwise, if the mid position value is greater than mid minus 1 is there. That means you have to search the right of mid minus 1. You have to search the left of mid minus 1. Okay, return -1 is the element is not found. In previous example, we are taking these elements 10, 20, 30, 40, 50, 60, 70. Our target is 50. Our target is 50. Next, we can find out the index value for binary search. How to find out the index value of binary search means the array elements and target. Finally, we can print the element will be available in that the element is available in that list array or not. So the 50 element is found at 4th position, 0, 1, 2, 3, 4, 5, 6. The 50 element is available in that 4th position. This is the algorithm. This is the program for binary search. Okay. Now the binary search can be used in, how to use the binary search in recursive manner, recursive method. The recursive method is follow the array elements, low, high, target. Okay, low, high, target. Now if low is greater than high, return -1. Next, we can find out the mid value. Mid value equal to low plus high by 2. That is this one. If array of mid equal to target, the program is completed. Array of mid equal to target value, the program return the mid value means we have to find out the element. Otherwise, array of mid is less than target, the binary search will be working. Array mid plus 1, high value and target value, that is to find out the right of, and otherwise mid -1 to searching the element in left of mid -1. Okay, this is the program for binary search by using the recursive method. Okay, so the binary search algorithm, every algorithm has find out the time complexity and space complexity also. Here the have to find out the complexity analysis of the binary search. How to find out the time complexity? Since the algorithm will start with middle element. The algorithm will start with middle element. This is the best case. It is possible to middle element of the array, that is the itself will the target element. Otherwise, the length of the array element is halved. Okay. Here we are follow the different iterations have to follow for finding the array element. So first initially the array equal to n. Iteration 1, the length of the array is n by 2. The second iteration n by 2 by 2, that is n by 4. Okay, it is repetition until the kth element will be length of the array means n by 2 power k. N by 2 power k. After k iteration, the size of the array becomes 1. It is can be narrowed down to the first element or last element only. So the array is n. The array is n. The first iteration n by 2. The second iteration n by 2 by 2. The third iteration n by 2 by 2 by 2. Like that, kth iteration, that is n by 2 power k. That is the complexity analysis for binary search. The length of the array equal to n by 2 power k, that is 1. Means we are length we have to find out the every time only 1. That is n is equal to 2 power k. Now we are applying the logarithmic function in both sides, that is log n base 2 log 2 power k base 2. Here log 2 power k means 2 power k is called as n. Okay, that is log 2 base n equal to k into log 2 base 2. That is log 2 base 2 value is 1. That is k into 1 equal to k. So finally k equal to log n base 2. At the time of the kth iteration, the complexity is log n base 2. See this example for the time complexity analysis for the binary search. In this array element, there is a 13 elements are there, 0 to 15. The key value is 13. Where is the 13? This one is the 13. Okay. The keys is 13. Here, in that we are searching the 16 element. So, first we can dividing this problem into sub problems na. 16 into 1 by 2, that is 8 elements. 0 to 7 is the 8 elements. Again these 8 elements can be dividing into 2 parts, that is 8 into 1 by 2 means 4. This 4 is this one. Again this 4 elements is dividing into 2, that is 4 into 1 by 2, that is 2. This is 12 and 13. Okay, 4 by 2 means 2 elements. That is the complexity for this one. Now the complexity analysis like this, key equal to 13. Here 2 into 1 by 2. Here the array is divided into 4 times. The array is divided into 4 times. In previous slide we will discuss in this one. The array is divided into 1 time, 2 time, 3 time. 1, 2, 3, 4. The array is divided into 4 times. Okay, 4 times. The required value of array is 16 elements. Therefore, the number of elements is n into 1 by 2 power k, that is n 1. Okay, n equal to 16. That is n equal to 16. We have to substitute this equation. 16 into 1 by 2 power 4 equal to 1. Coming to this one. Okay. Here the time complexity analysis for the binary search means to multiply with both sides 2 power k. 2 power k. 2 power k into n by 2 power k equal to 2 power k. Okay. That means n equal to 2 power k. This will 2 power k. Okay. That is multiple by both sides in 2 power k. Now, to convert this result into logarithmic value, to successfully get the 0 of log n for the time complexity, we have to find out the time complexity for this binary search is, best case is 0 of 1, average case is 0 of n log n, worst case is 0 of log n. This is the time complexity for binary search. Okay. Now, what about the space complexity? The space complexity of binary search is there is no use to any extra space for searching the element. So, the space complexity of this function, this binary search is 0 of 1, equal of 1. Okay. This is the binary search. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.